Okay, so now we're looking at the calculator portion of the 2012 AP Calculus BC exam. So starting off with number 76, we're given a graph, which is defined on the interval -2 to 2, and which of the following statements about the graph is false. So first off, f is continuous at x equals 0. Well, looking at the graph right here, there's no holes and there's no asymptotes at x equals 0. So therefore therefore f is continuous there. So we can cross this off. F is differentiable at x equals 0. Well, one thing I notice is that there seems to be a sort of a sharp turn at x equals 0. So, and at like sharp turns, functions aren't differentiable. So I would say B is probably the answer, but let's look at the rest of the answers. F has a critical point at x equals 0. It definitely does, because here a critical point occurs when the derivative of the graph is either 0 or it is undefined. And since this is definitely either 0 or undefined because it is changing direction, or since it's a sharp turn, it's undefined. So C is wrong. D, F has an absolute minimum. Yeah, we can tell by looking at the graph that that is in fact an absolute minimum, and the concavity of the graph does change because this is concave down, this is concave up, so that's wrong. So B is our answer. All right, 77. Let f and g be the functions given by f of x equals e to the x and g of x equals x to the fourth. In what intervals is the rate of change of f of x greater than the rate of change of g of x? So, this one, we're going to have to use our graphing calculator. And so, I think the easiest way to do this is just to graph the derivatives of each of these. So, f prime of x equals e to the x, and g prime equals 4x cubed. So, I mean, you can solve this like by setting these equal to each other and finding out where they intersect, and then finding out which is greater on each interval, which you would actually need a graphing calculator for still. But I think the easiest method is just to graph them. And if we graph each of these, let me just grab my graphing calculator. So we have e to the x. I'll draw a graph. Over to the side here. And so e to the x is going to look like, actually I'll use a different color. Oh. There we go. Let's use, I guess we'll use this. So this is e to the x. It doesn't actually cross the x-axis. I'm just not being super precise right now. Here, let's see if I can move this. Okay, never mind. And now for 4x cubed. 4x cubed. Basically looks like, use a different color. Looks like this. And, okay, let me redraw this first graph. So it's more, sort of, there we go. There, it's a bad picture, but we can see that, or the rate of change of f of x. So where's the rate of change of e to the x greater than the rate of change of x to the fourth. Well, the yellow one is e to the x, so we can see it's greater from here back. Oh, whoops. From here back to negative infinity, and from here to positive infinity. And so you can use the intersect function on the calculator to see where these are, and they happen to be at 0.831 and 7.384. So B is our answer. Now 77, so 78. The graph of piecewise function is shown above. What is the value of -1 to 9 of 3, or the integral of that? So let's see. First, I think we're just going to want to solve the integral. So we'll isolate the f of x to make this easier. So change this to 3. Plus this dx here, dx here. And let me see, is this in parentheses? Let me think about this for a second. Yeah, this should be in parentheses. So now, I mean, this part's easy. It's just 10, because this spans 10. So -1 to 9 is 10. 10 times 2 over 3 is 20 over 3. And then from -1 to 9 of f of x dx is its graphed. So we can see that this part is negative and this part is positive. So we'll add this negative, let's see, 1, 2, 3, 3.5. And then there's this positive 1, 2, 3, 4, 5, 6 times 2 times a half is 6. So 6 minus 3.5 is 2.5, or 5 halves. And then this is all multiplied by 3, which equals 15 halves plus 20, which is 7.5 plus 20, which is 27.5, or C. Okay, now moving on to 79. Let f be a function having derivatives of all orders for x is greater than 0, such that f of 3 equals 2, f prime of 3 is -1, and f double prime of 3 is 6. Oh, and f triple prime of 3 is 12, which the following is the third degree Taylor polynomial. Oh. Okay, about x equals 3. So Taylor polynomial goes in the form the nth derivative of n, or the nth derivative of f, at a over n factorial times x minus a to the nth power. And so we can just plug that in here. So 0 factorial and 1 factorial are both 1. So in the first two cases, it's just 2. Then minus 1 over 1, which is 1 x minus a to the first power, plus 6 over 2 factorial, or 6 over 2, or 3 x minus a squared, plus 12 over 3 factorial, or 12 over 6, or 2 x minus a cubed. Or x minus a should be, a is 3 in this case, so there we go. And so that one is, let's see, E it appears. Yeah. Okay, cool. So 80, the graph of f prime, the derivative of f, is shown above. Which of the following must be true? F has a relative minimum at x equals 3. All right, let's see where x equals 3, or negative 3. So the derivative does equal 0 there. So that is one sort of requirement for a minimum or a maximum. But now let's see before negative 3, so at like values less than negative 3, the derivative is negative. And then at values greater than negative 3, the derivative is positive, so it's increasing. So the graph of f will look something like this at negative 3. X equals negative 3. So one is correct, one works. So now moving on to number 2, the graph of f has a point of inflection at x equals negative 2. So x equals negative 2 is right here. And a point of inflection is when the concavity of the graph of f changes. And so that means there's a sign change in the second derivative, which would mean a change in the derivative of this derivative graph. So that doesn't happen in this case. The derivative of, it's kind of confusing to look at it this way, but the derivative graph at x equals 2 or x equals negative 2 continues to increase, meaning the derivative of this continues to be positive, so there is no point of inflection. So 2 doesn't work. And now the graph of f is a concave down for 0 is less than x is less than 4. Let's see. So this interval. And we can see that the graph of f prime is decreasing all across this interval, which means the graph of f double prime is negative, which means the graph of f is, in fact, concave down. So both 1 and 3 work. So E is the answer. 81. So let f be a function twice differentiable on negative 2 to 2 and satisfies the conditions above. If f of x equals f of negative x, what are the x coordinates of the points of inflection of the graph on on this interval? So points of inflection again are when the derivative or the concavity of the graph changes. So that's seen in the second derivative. The second derivative flips like it does in this case between negative and positive at x equals 1. So that means x equals 1 is one answer. But also, this is only on the intervals 0 to 2. We also have to worry about negative 2 to 0, that interval. But it gives us this information that f of x equals f of negative x, which means that f of negative 1 equals f of 1, and like f of like negative 0.5 equals f of 0.5. So the graph will look something like, for example, this, where there's a point of inflection here, and this is it's going to be symmetric about the y-axis. So there will be a point of inflection at x equals 1, but also at x equals negative 1. So D is the answer. All right, 82. What is the average value of y equals cosine square root of y equals the square root of cosine x on the interval 0 to power 2? This is pretty simple as long as you know the average of a function over a certain interval formula, which is 1 over b minus a, the integral from a to b of whatever function. And so in this case, we're going from 0 to pi over 2, so it's 1 over pi over 2, like this. And you just type this all into the calculator, and you get 0.763, or C. 83. If the function f is continuous at equals 3, which of the following must be true? So if a function is continuous, that means that at a certain x, that means that f of x equals the limit as x approaches. Well, I guess I'll use at a certain value a, like this. If a function is continuous, this will be satisfied. So that means that, and then I guess another thing that they're trying to test you on is that to see if the limit as x approaches a exists, then it must approach the same value from either side. Like so. And so, given that, we can see that C is the answer. All right, 84. On this interval from -1 to 1, or from -1.5 to 1.5, the f be a function first derivative given by this. Well, which of the following are all intervals on which the graph of f is concave down? So, concavity, we are looking for the second derivative, and it already gives us the first derivative, so we'll just differentiate this again using the what's it called? The power rule and the chain rule. So bringing down the exponent. Or wait. No, sorry, I'm thinking of something else. The derivative of this is just, and then we obviously have to chain rule, so 4x cubed minus 4x. So this must be, okay, so it's concave down, so this must be less than 0. So we'll just plug this in to a calculator, and we get that the graph, or there's intersections at -1 and at, wait, oh no, I think, yeah, no. You could do it like that, but you can also just graph it and see that D is the correct answer. Okay, moving on. 85. The fuel consumption of a car in miles per gallon is modeled by this, where S is the speed of a car in miles per hour. If the car is traveling 50 miles per hour, its speed is changing at a rate of 20 miles per hour squared. What is the rate at which its fuel consumption is changing? So this is it's a related rates problem, right? And also like an implicit differentiation problem. Okay, so we're trying to find out let me highlight, what is the rate at which its fuel consumption is changing? So fuel consumption is F of S. So we're trying to find dF over dt. So in order to find that, we have to differentiate both sides with respect to time. So differentiating the right side, we get 6e to the s over 20 minus s squared over 400. And then using the chain rule, we get times 1 over 20 minus 2s over 2400, or s over 1200. And then again using the chain rule, we have times ds over dt. And I also forgot that the ds over dt on this side. There. So ds over dt is the rate at which s, the speed of the car, is changing with respect to time, which is the 20 miles per hour squared that it has given us. So, and then the speed it's given is 50 miles per hour. So plugging all those in, we get 6e to the 50 over 20, or 5 over 2 minus 50 squared over 2400 times 1/20th times 20 minus, what is that, 50 over, like so. And so what this equals is 4.299, or B. Okay. 86. If f prime of x is greater than 0 for all real numbers x, and this integral equals 0, then which of the following could be a table of values for the function f? This is a kind of a peculiar question. But if, okay, so if f prime of x is greater than 0, that means the function must always be increasing. So as x increases, all the values must increase. So let's see. Is there anything that already doesn't satisfy that? Well, c doesn't satisfy that. D doesn't satisfy that. And all the rest do satisfy it. And now the other thing is that from 4 to 7, so across this range, the function is equal to 0. Or the integral, the definite integral from 4 to 7. Which means that there must be positive and negative values that cancel out to equal 0. Which means that this could be a table of values because it spans positive and negative values. A only spans negative values, and B and E only spans positive values. So those would get a negative and positive value of the integral respectively. So B is the answer. Okay, now 87. Let R be the region in the first quadrant bounded above by the graph of y equals ln of 3 minus x. Oh, it is the base of the solid for which each cross-section perpendicular to the x-axis is square. What is the volume of the solid? So this is a solid, or it's like the volume of a solid with a known cross-section or something. I think that's what they call it. But basically, we have to keep in mind what the cross-section is. So it's a square in this case, which is probably one of the easier ones. And I'm just going to sketch the graph just to make this a bit easier to understand. So it's in the first quadrant, bounded by the graph of y equals ln of 3 minus x, which looks something like this. And so this is the base, and the length of this base is the same as the height of the solid at that particular point. So because it's square cross section, so it's kind of like, I'm just drawing certain squares to make this, to sort of illustrate what this looks like approximately. And so it's going to look something like this. Whoops. There. Something like that. And so what we're going to do is we're going to take this normal integral, because normally to find just the two-dimensional area, we take the integral from, let's see, it said 0 to 2 of ln 3 minus x dx. But since we are taking the volume of a square, well, how do you find the area of a square? It is side squared. And so this is one side of the square. So this is the other side of the square. So the function is one side, which means we can just square the function in our integral and then take the integral of that. And what we end up with is our answer, which is 1.029, or B. Okay, moving on to 88. The derivative of a function is increasing for x is less than 0 and decreasing for x is greater than 0. Which of the following could be the graph of f? So increasing for x is less than 0. Oh, the derivative of a function is increasing. Which means it has, for x is less than 0, there's a positive f double prime of f, which means it's concave up for x is less than 0, and concave down. By the same logic, it's concave down for x is greater than 0, which means it must be E. So now 89, particle moves along a line so that its acceleration for t is greater than or equals to 0 is given by this. If the particle velocity at t equals 0 is 5, what is the velocity of the particle at t equals 3? Okay, so what we have to know is that we can take the definite integral over a certain range to find out the change in the, so in this case it would be the velocity function over that range. So we can integrate the acceleration function from 0 to 5, or no, my bad, 0 to 3. Because we know t equals 0, we know what the velocity is at t equals 0, we want to find what it is at t equals 3. So when we do this, we end up with 6.71, approximately. So we know from 0 to 3, the acceleration, or the velocity, increased by 6.71. And now we also know that when t equals 0, the velocity is already 5. So we just add 5 to this and we get 11.71, which is E. Okay, now 90. If the series, the infinite sum from n equals 1 to infinity of a sub n converges, and a sub n is greater than 0 for all n, which of the following must be true? So the first one looks like the ratio test. The limit as n approaches infinity of a sub n plus 1 over a sub n. The absolute value of that equals 0. And that is not necessarily true. We know the series converges, so all that needs to happen to satisfy the ratio test and for the series to converge here, I'm not going to write this, is for this to be less than 1. But since it's not, or since this is saying equal to 0, it could be equal to 0, but it doesn't have to be equal to 0, so A is not right. The absolute value of a sub n is less than 1 for all n. No, that's not necessarily true. Because if we take, for example, I don't know, let's take a P series, which we know converges, 1 over x2, or wait, 1 over n squared. We know this converges. And all of these are less than 1, n equals 0. Wait, equals 1. So all of these are less than 1. However, we can just easily, say that the first term is going to be like, or no, the first term is 1, so that already doesn't work. But we could also easily say that it's like 2 times, this. And this series still converges. So, yeah, that B is not true. Now C. Okay, so this is saying that the series must equal 0, which it could equal 0. Actually, no, it can't equal 0 because it says a sub n is greater than 0 for all n. So no, it can't equal 0. But even if it didn't say that, it doesn't necessarily have to equal 0. Now we are saying that, we're modifying it. So n times a sub n diverges. So let me think about this. That's not necessarily true because even as n gets really big, a sub n is going to get really small. So it doesn't necessarily have to diverge. So D should be wrong as well. And then let's look at E. Now we're doing a sub n over n converges. And this is clearly the answer because n starts at 1 and only grows bigger, which means for every value, a sub n over n is going to be smaller than a sub n always, which means since it's smaller, it must also converge if the original series with a sub n converges. So E is the answer. Now 91. The figure shows the graph of the polar curves. Those was the sum of the areas of the shaded regions. Okay, so there's a bunch of different ways to sort of divide this this graph into different regions to find the area. I think the easiest way to do it is, since we know the area of the circle, I'm just going to subtract out the area of all of these petals. And what I'm going to do is just going to find the area of one of them and multiply by 3 because they're all the same area. So what I want to do is see, when do these petals close? Or in other words, when are they equal to 0? When is r equal to 0? So let's say 0 equals 2 cosine 3 theta, which means cosine of 3 theta is 0. So theta equals pi over 6, because pi over 2, cosine of pi over 2 equals 0. And also cosine of 3 pi over 2 equals 0, which means pi over 2. So that means at pi over 6, this is 0, and at pi over 2, this is 0. So what I can do is I can take the integral from pi over 6 to pi over 2, and it's actually 1/2 times the integral of this of the integral of r, so 2 cosine 3 theta squared, and this is going to be this highlighted red area. And so we just have to multiply that by 3. to get all of the petals. And this equals, actually equals pi. So then we want to subtract the area of the bigger circle, or we want to take the area of the bigger circle and subtract what we have. So the area of the bigger circle is pi r squared, or 4 pi, because pi 2 squared, and subtracting pi we get 3 pi. And multiplying that out, it is around 9.425, or D. All right, and now 92, this is the last problem. The function h is differentiable, and for all values of x, h of x equals h of 2 minus x. Which of the following statements must be true? This is also kind of a weird one. Let's see. So from the integral from 0 to 2 of h of x dx is greater than 0. No, that's not necessarily true, because I can give this example. If you have a graph and the line is just flat all the way, it does satisfy h of x equals h of 2 minus x, and the integral from 0 to 2 of this function is 0, which is not greater than 0, so 1 is not right. 2, the derivative of h, or the derivative at x equals 1 equals 0. I do believe this is true, because this graph for this is essentially saying that at a certain x, it has the same value that a certain x, 2 units away has. So, or wait, not necessarily 2 units away, but it's like the same area or the same value at 2 minus x. So that means that I think the derivative at all x's must equal 0. So 2 should be right. And this is saying that the derivative must equal 1 at these 2 specific places, which doesn't make any sense to me, like why it must equal to 1. I guess it's because it's these are at the same spot. But that's not necessarily true. And if we look at the logic that led us to say that 2 is correct, then I think we got to say that 3 is wrong. So the answer should be 2 only, B. And that was the last problem. So hopefully that was helpful in the calculator portion.